Hello everyone, welcome to this video. In this video, we'll be looking at another question from IIT-JAM 2022. Right? In this question, they are asking if we are given a system of linear equations. So here we have x, y, z and t as 4 variables and 4 equations are given to you. Right? So in this case, they are saying what depending on this value of lambda, for which value of lambda we have the following option correct. So whenever lambda is 1, then the system has unique solution or infinitely many solution, or whether it is 2, then the system has a unique solution and infinitely many solutions. So this is the question. So how do you solve such kind of systems? We convert this system into the form of this A augmented P matrix, where you first of all write your given systems in terms of matrix and then solve them in order to obtain the unique solution, multiple solutions or no solutions. So let's see what do we have in our case. So for that, first of all, just we can write the given equations, the given linear equations in the form, the given linear equations in matrix form as follows. How? So you could write it like this: all the coefficients in one matrix. So your first would be 1 1 1, z is 0 here, so 1 1 0 1, right? Here you have the matrix x, y, z and t, and the right hand side matrix, it would be the right hand side, so 4 7 5 and lambda, right? And your this coefficient matrix, for the second equation, the coefficient of x is 2, y is 0, z is 0, for t it is -4, right? For the third equation, the coefficient of x is 1, y is 1, z is 1, t is 0, and for the last equation, the coefficient is 1, then -3, then -1 and then -10, right? So this is the matrix in the given form. So here what we do, we create an augmented matrix of this kind A, B, right? So here if we say in the matrix form as AX is equal to B, then we can write it, this in the augmented form as the matrix 1 1 0 1 augmented with 4, right? So we are writing the elements of one row together. Next would be 2 0 0 -4 with 7, then it is 1 1 1 0 with 5, then it is 1 -3 -1 and -10 with lambda. So this is our matrix, right? Now what do we do here? We will make this in the echelon form, right? So we will make this element as 0, this element as 0, this element as 0. So how can we do that? We'll use row 1 for this. So on R2 we'll apply the operation that R2 minus 2 times of R1. Then on R3 we'll apply the operation that R3 minus of R1. Then on R4 we'll apply the operation that R4 minus of R1. So these operations we will apply here. So here you can copy down your first row as such. So it is 1 1 0 1 augmented with 4, right? Next 2 minus 2 is 0, 0 minus 2 is -2, 0 minus 0 is 0, then -4 minus 2, that is -6, right? And then 7 minus 8 is -1. This is for second row. For the third row we have R3 minus R1. So we have 1 minus 1 as 0, 1 minus 1 as 0, 1 minus 0 as 1, 0 minus 1 as -1, 5 minus 4 as 1. And for the fourth one we have R4 minus R1. So what do you have here? 1 minus 1 is 0, right? Then you have -3 minus 1 is -4, -1 minus 0 is -1, -10 minus 1 is -11, then lambda -4. So this is the matrix that you have after calculation. Now next, what do we wanted to do here? We wanted to make this element as 1. So how we can make this as 1? On R2 we'll apply R2 divided by -2. So we'll divide by the same element in order to make it 1. So all the other elements in row 1, 3 and 4, they'll be as such. So we can just copy down all the other elements first of all. So you have 0, minus 4, minus 1, minus 11, and then lambda minus 4, and onto the element of R2 we have to divide all the elements by minus 2. So it is 0 divided by minus 2 is 0, minus 2 by minus 2 is 1, 0 by minus 2 is 0, minus 6 divided by minus 2 is 3, and then minus 1 divided by minus 2, that is 1 by 2. So this is our matrix after calculation. Now next, what do we wanted to do? We wanted, this element is already 0, so no need to perform anything. We wanted to make this element as 0. So on R4 we'll apply the operation that R4 minus 4 times of R2. So basically we'll multiply this by minus 4 and then subtract both of them in order to make this as 0, right? So the elements of row 1 would be as such 1 1 0 1 with 4, row 2 would be as such 0 1 0 3 and 1 by 2, row 3 would be as such 0 0 1 minus 1 with 1, right? And then for R4 we'll apply operation R4 minus 4 of R2. So 0 minus something 0 is 0 only, 4 minus 4 of 1, that is 0 only, then minus 1 times minus 1 minus 0 times something, so that is minus 1 only, right? Next element is minus 11 times minus 11, then you have minus 11 minus of minus 4 of R2, that is 3. So you have minus 11 plus, what is it, 12. So you have plus 1 here. And lastly you have R4. For R4 what do we have here? For R4 the element is lambda minus 4 in R4, minus of minus 4 times of R2. R2 is 1 by 2. So when you solve this you have lambda minus 4 plus 2. So it is lambda minus 2. So you have lambda minus 2 here, right? So this is the member. Now next, what we wanted to do next, here if you see we have 1 with all zeros, then 1 with all zeros, then 1 here, no problem. So we will have to make this as 0. So how we can do that? We can apply the operation onto R4, that when you add R4 with R3 you have the element of R4 as 0, right? So that means the elements for row 1, 2 and 3 would be as such. So let's copy them down. 1 1 0 1 with 4, right? 0 1 0 3 with 1 by 2, then 0 0 1 minus 1 with 1, and for the last element we have to add row 3 and row 4. So it is 0 only, 0 only, it is 0, it is 0, and when you add them this is lambda minus 1, right? So here if you see we have, after calculation, our element, our matrix, augmented matrix in echelon form. So now here you have to see what is the rank of matrix A. So if you see you have the matrix A up to here, right? It is the number of non-zero rows. How many such rows are there? We have 3 in total, right? So this is the rank of A. And what is the rank of A augmented with B? So that means now we are talking about this whole matrix, right? So it is the number of non-zero rows. Now it would depend upon the value of lambda. So in this case you have the number lambda. If lambda is equal to 1, then you have lambda minus 1 is equal to 0. So that means the last row would be 0, and in this case the rank of A augmented B would be 3, right? If that is so in this case your rank of A would be equal to the rank of A augmented B, and it is equal to 3, which is less than 4. And what is 4? The number of unknowns. So that means in this case you will have multiple solutions, and if for this, if lambda is not equal to 1, it is any number except 1, in that case lambda minus 1 would be not 0. If this is not 0, that means you have one element which is present in this augmented matrix in the last row as well, so its rank would come out to be 4, because in that case it would have 4 non-zero rows, right? So in this case the rank of A would not be equal to the rank of AB, right? So in this case you would have no solution. Why? Because we have this result that whenever the rank of A is equal to the rank of AB and further they are equal to the number of unknowns, in that case we have unique solution, right? If this is first case, in the second case, if rank of A is equal to rank of AB but it is less than the number of unknowns, then in that case we have multiple or infinite solutions with us, right? And in the third case, whenever the rank of A is simply not equal to the rank of A augmented with V, then we have no solution present with us. So I hope you understood this solution. So what is the answer? The answer, either we have no solution in this case or we have multiple solutions when lambda is equal to 1. So let's see at our options. So in our options we are given that whenever lambda is equal to 1, obviously we do not have any unique solution, so this option is incorrect and this option is incorrect, and we are also not talking about lambda is equal to 2. So whenever lambda is equal to 1, the system has unique solution. So here the option C is the correct option. So I hope you understood this question well. Well, that is it for this video. Thank you for watching.